Hello,
Hi, how are you?
I'm good. How are you?
All right.
So I actually didn't do much this week. I've just enhanced it a bit, not much. But yeah, I was busy in college this whole week. Okay, so this was for week 8, but now this is week 9 actually. So week 9 is supposed to be having the whole interactive GOI and everything. And oh yeah, I already started with something last week. So these are the two metrics, and this is the recap of how the whole simulation looks like, which agent has contributed which much and how much and in which domain. So yeah, like last week, my visualization looked a bit different. This time it's a bit bigger, like it's bigger and it has more things like logs and graphs. Last time it was only logs and the graphs were coming like separately. So here we have an option to save the graphs as well. Like already they were getting saved, but they were getting saved with the data like in my VS Code or whatever, like at the back end. So now with the UI, you can save it in the front end as well. And like today, like when I came back from college, I added this visualizer, but like yeah, it's not completely working right now. I haven't visualized anything because I didn't get much time. Hopefully I can progress over it over the weekend. So yeah, and yeah, it's more or less the same thing. And I updated the readme according to what has been done and added a blog for week 9. And yeah, I was supposed to meet Sarah last week, but I couldn't. So like tomorrow we have scheduled a meet.
All right.
Yeah.
That sounds good. Looks like yeah, we did have a discussion in Slack about visualization, and so it looks
Right.
like you got that in. You mocked something up, so that's good.
Yeah.
So the visualizer, could you show it again and kind of
Yeah.
talk about
Sure.
your plans for it?
So yeah, this is the visualizer. Like it's the same thing. Like you know how we can see the logs over here, like in the logs tab, and then the graphs will come separately. Like these graphs will come in the graph section. So like the visualizer actually doesn't have anything right now. It's empty. Like I don't know what I can visualize. Probably something like which had been done using NetLogo 2 years ago in 2022 or like 3 years ago. I don't know exactly what they had done, but I think it was something like the agents are moving and the tasks are there. So around something like that where I can show, like I can actually visualize it. So I'm trying to use Pygame or other, like I think Tinker has or Matplotlib has this animation tool. So I'll probably use something like that to get the visualizations. So like yeah, I mean I don't, do you have any suggestions?
Yeah, something like a net logo interface is usually pretty effective.
Okay.
Yeah, so like if you have, um, if you look at like some of the examples of net logo, especially that people have worked on in projects past, but also some of the demos that they have for net logo, like just to see what that looks like. It's basically just a bunch of agents or a bunch of squares, and then they change color, and it just
Hmm.
shows that spatial aspect of the simulation and how different agents are propagating different strategies across the space. You might have to think about how you're going to represent them as a grid. So, like if you have a bunch of agents, how can you represent that as a grid? So that's key. You could also do other visualizations. You could do a network visualization, which would be like where each agent would be a node, and then you'd have some edge connecting them. Maybe they participate in the same
Okay.
task. I mean, there are different ways you can visualize it. I would try to think about like what is the fundamental relationship that is important to getting
Hmm.
the task
Okay.
completed. Jayadratha, hello.
Hi,
Hi, how are
hi,
you?
brother.
Hi.
Yeah, I'm good. Everything okay? So, should I continue with my presentation today?
Yeah, go ahead.
Okay.
Yeah, yeah.
Yeah. So, last day I have shown, like I have created this discrete time temporal graph data set, and here one thing I didn't add, that is I didn't actually find at that time. So here, if you see, there are different colors. and these color codings are for different kind of synopsis. I mean, different kind of what you call it, uh, like a neuron. So like this one, BWM, this is for muscle. ILI, IL1, this is for motor neuron. IL2 sensory neuron. So these things I found in this paper. They have shown written in the last page and here. So I have taken all of them and tried to add in my uh, like code uh, just for visualization, like good visualization. So I have added this, and now I have done visualization. Last day I have created this temporal graph, and now I have created the visualization. So here I have like written the data loading part, and then at first I have started with static visualization. So in static visualization, this is a visualization for network growth, that is ages and synapses, that how it is increasing with time. So this red one, this is for total synapses, and that is changing with time. Time means L1, L2, L3, L4, L5, L6, L7, and L8. So like that way. And here number of ages, how number of ages that is increasing. So that means how number of connections that is increasing with time. So here from this graph we can see clearly it is increasing with time. Only here number of ages that decreased a little, but otherwise the trend is it is increasing with time. Uh, so this we can see here as well. Uh, So here also number of connection increases. That's why like number of synapses they have increases with time because it is going from birth stage to adult stage. So connections, synaptic connection grows here with time. So like this is a weighted graph and also a directed graph. So I tried to build that here. So here, like how electrical synopsis and chemical synopsis that is like increasing with time, that I have shown here. Similarly, this is here also from birth to the L8 or adult phase. So here also clearly it is increasing number of synopsis and its connection. And in the next graph, I have shown how average node degree and the connection density that is changing with time. So here also like this is average node degree. Average node degree is nothing but like how many number of so one node that is connected to other nodes. So it is connected to its neighbor. And also here I have tried to show the connection density. So connection density is like how many new uh, ages that are coming, that is also increasing with time. So as it is going to adult phase. And now I have taken one like one of the phases. So suppose I have taken adult phase, so that is the last time point, that is L8. So I have taken this L8 and like shown here, but we can take any timestamp. It can be L1, L2, any of them. So here I have tried to see which of the like node that has most connection and the most degree centrality. So so here we can see these are the top like top 10 I have shown here, the degree centrality. So these are the different uh, nodes or I mean what you call it, different like this is one node. So I mean, these are the what are the neurons that are available, and these are the top 10 neurons that has most connection. And then I tried to build the network visualization here. So if we see, so this is the visualization we can see. So these are for some kind of like these are for modulatory. These are uh, 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 I mean, these are different kind of uh, neuron that are available here. So some are muscle, some are modulatory, and like these are different neurons. So I also try to see neurons, different kind of neurons with different color coding. So here what I have done, I have taken only top 50, because otherwise like I will show the like how it is changing animation. There I have taken all of the nodes, but here I have taken only top 50, because otherwise it was uh, like getting very we cannot see and distinguish. So this is the different kind of neurons, and their how they are connected to each other. So here this like gray like its strength, that is how many synapses are there, this strength shows. And this like connection, this is showing who is connected to whom and its direction. And so here if you see, some of them are not very I mean, some of them are thick, some of them are not that thick. So that means thick means there are strong connection, and these are not very strong connection. And these are the different kind of like neuron type: intermodulatory, sensory, motor, muscle, etc. So here I have some top 50 nodes from adult, and now then I have created this from birth to uh, like till adulthood. I have created for all the nodes, or all the uh, mm, like neurons. So I'll show the visualization. I have so if you see here, so this is timestamp 2 and then timestamp 3. So I have taken in like 2 seconds gap, uh, then type 10.6, 7, and 8. So we can see here it is increasing the connection with time. I'll show you again. So this is so timestamp 1, that is at birth stage. There are not many synapses that are connected, and then at timestamp 2 there are new connections that are generated, or also the strength is also increasing. And then timestamp 3, it is further increasing, and till adult phase uh, it has the most connection and dense connection as well. Yeah, so today I have done till this point. uh, so if you have any questions or anything you want to, any input. uh,
Yeah. So we'll go back to the notebook. The
yes, yes,
first graph you showed about, let's go up further, up further.
yeah,
This one here. This is top 10 most central neurons in adults. This is degree centrality.
yes,
This is an interesting graph because there's a paper from about 2013
yeah,
on rich club neurons and C. elegans connectome. And what they
okay,
mean by rich club is they mean like there are neurons that are highly connected, or a certain class of neurons that are highly connected, much more connected than any other neurons in the connectome. And it'd be interesting to compare this graph, which this is going to be a little bit different measure. This is degree centrality, but to see how those compare. And I think there I see some that are, from what I remember of that paper, I see some similarities there, where
okay,
they basically define that for the adult. So I'll send you that paper
Yeah, that will be great.
Yeah. Um, and so the hypothesis there is that um, the connectome is hierarchical. So you have a subset of neurons that are highly connected and serve as these hubs for processing. And so I think that's what you might be seeing here in a different way. But that's good that you have that. You might
Yeah,
actually run this if you can for some of the time step, like for some of the synaptic.
yeah,
Um,
that I can do now only. Like
yeah.
if we just change from 8 to some other 2, we'll find for 2.
Okay.
Uh,
Oh,
yeah.
there we go.
So
Yeah.
this is for like this is not for adult. I have to change in writing here. This is for L2. So this is for L2 page.
Oh
Yeah.
wow.
So degree centrality. So
Yeah.
yeah. So like we can do that for any of them from 1 to 8, all any stage from birth stage. If we keep it 1, then we'll get for birth stage, and for others we'll get accordingly.
Yeah. That's
Yeah.
pretty useful. That's good. We'll have to follow up
Yeah.
on that.
Okay. Thank you.
The other thing, yeah, I like the visualizations of the network. So, if you go down to well, the first network you showed wasn't circular, but it was. We'll get back to that actually. But
Okay.
go down to the network visualizations.
Yeah.
That one is
Yeah.
not circular. That one is that's kind of force
Yeah.
directed. Yeah, and it's
Okay.
interesting. Um, but go down to the circular graphs if you could.
Yeah.
Yeah,
Yeah.
those.
Right.
So yeah, those are good. Yeah, um,
Mhm.
and the thing there is they're not anatomical, so it takes it out of that context. Neither is the force directed one, but it does show you kind of these like the density. I like the way the density changes. You can see
Mm.
that as you move through. Um,
Yeah. For the animation, right?
yeah,
Yeah.
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 But of course, then the thing is you want to know why, what the significance of that is. Like that's the thing about a lot of networks is that they have like this, they show pretty pictures, but like, what does this mean in terms of what we're getting out of the data? And a lot of times it's like, well, you have to make some statements that are not, they're kind of broad strokes. So yeah, this is good though. I like that you have these animations. They
Okay.
really do show, yeah, like the big picture. Um,
So
yes.
does it? Uh, Sorry to interrupt.
Oh, go ahead.
Uh, yeah, does it mean that as C. elegans going from like birth to adult, that means it is getting older. As it is getting older, then it has more neuron, like more connection or connection strength of the connection that is increasing. So that's why it is getting like broader and broader these connections. So is it like it signifies that, right?
Yeah, basically, um, just
Hmm.
a denser set of connections.
Hmm.
So, I mean, what is the temporal graph approach? How does it like kind of? Because I mean, you could have like a static graph, a bunch of static graphs stacked on top of one another, and you could show that. But how does the
Yeah,
temporal graph approach allow us to approach this maybe differently than the static graphs?
yeah, yeah. Actually, I mean, for this one, through temporal graph, what I wanted to do is, like, can we get some intermediate step? Suppose from L0 to L1 to L2, if there is an intermediate step, what the connection will look like, or something like that. So, suppose here we have shown, like at time 0, then maybe at time 5 and 8, like that. So can we uh, through this network, can we predict what would be the intermediate step here? That is what the goal was, but in the visualization, like for that, I'll run some network in the next meeting, and I'll show, I mean, probably, like, because now the network that are there. So I want to show like these papers. So this is one paper, Evolve GCN, that I have shown before, and here also what it is doing, it is like intermediate step. It was trying to find the link prediction. I mean, if these if there is any link that does not exist, will it be like, can we tell that it will exist at some intermediate step? But one thing, I'm not sure if I can create the entire, I mean the intermediate step. So for here, what they do, they have suppose like 20 different timestamp, and then they want to see after like 21 at 21st timestamp, for one, I mean this connection they want to see, and or predict if this connection, how, like only one connection it want to see. So how strengthened this connection is, or if there is any connection at all between these two uh, neuron. So this is what like these papers they have done, they have worked on. But like for a entire graph generation in the intermediate step, that I have to see how is it is it feasible. One thing that is like one thing I have seen here, that for from like L1 to L8, the number of nodes, those are almost similar. No new nodes or no new neurons that is coming. But what that is changing, that is the strength that is changing between two nodes, or there was no connection between these two nodes, but in the later phase, we can see there are some connection that is coming. That means some synapses that is coming. So like that is what I wanted to do. But let's see how, like if that was the goal initially. I mean, I have to see if how feasible it is.
Okay. Yeah, that's great. And then this connection density versus time says, and then, well, this is a graph where you have connection density on the left, average node degree on the right. So this is like kind of the purple is average node degree, the green is
Yes.
connection density. So they're basically the same until they reach about 27 hours, maybe that
Yes.
sampling point, and then up, they go up. But basically, uh, for most of the data, for most of the sampling points, it's the same, and then it diverges at the end. So that's interesting. Yeah, I'm not sure why that would be, but I guess it's just kind of like that's where things are maybe consolidating a little bit more. Not really sure. But yeah, that's a good graph. Don't you have another graph as well? The
Yeah, this one, electrical
chemical and
activity.
electrical synapses. So those are interestingly they track. So like they're they kind of remain the same proportion. Maybe the electrical synapses are a little bit more prevalent later, but not necessarily. It's
Yeah.
interesting. That might actually reveal some that little joggle between 20 and 30 hours
Yeah.
might reveal some sampling thing in the data set. I don't know, but who knows? Go up a little bit more.
Yeah.
Yeah, that one. That's edges, and so number of edges, number of total synapses in terms of weight. So this is so what's the why is there a difference between number of edges? Well, I guess it's not
Uh,
really a change in the number. It's just kind of like the
yes, it's just
proportion.
the number.
Yeah.
Uh, yeah.
So are there
So
edges that aren't synapses, or what is this measuring exactly?
yeah, synapses are like how many for each age means one neuron is connected to another neuron,
Okay.
and the synapses is how many synapses are there. I mean, how many connection. I mean, it is showing the strength. So initially, suppose uh, between two nodes there were only one connection, and after some time it strengthens. So it gets more. I mean, from one connection to six connection. So like with one example, I can show. So here, this ADAL and AIAL. So this is presynaptic neuron and postsynaptic neuron. So there is one connection between ADAL and AIAL, but number of synapses that are two. So here also there is only one connection, but synapses, number of synapses are one. Here number of synapses increased to 7. So here what I wanted to show, that how many connections that are there. So if we see here for like graph 7, there are 2494 number of connection, 2493 number of connection, but how many total number of synapses that are there. So that is what I wanted to see here. So
Okay.
yeah, so sorry. So here if you see like for 2494 number of nodes that are there. If you see here 2494, and
Okay.
how many total number of synapses that are there, those are like more than 8,000. This is just tracking the like this I mean, this is just tracking number of total synapses and number of edges. So here as I have shown here, if we add here 7867 sum, that is the total sum, and we can see here also around 8,000. You see 7,800. So total number of edges that are 224 something 98, and here the total number of these are the total number of synapses.
Okay. Yeah, I see that. There's some interesting distributions, though, amongst the data. If you go back to the data table,
Yeah.
yeah, like some of them have a lot of synapses, some of them have very few.
Yes.
Which would be interesting to look at that weight distribution, like.
Yeah, so that is what I tried to show here. So if this is 10, 10 number of synapses, that means the connection strength is more here.
Right.
So that is what I have shown here. Like this connection strength, this is more black, and width is also more. So that means it has maybe 10 connection or 20 connection. And here it has maybe one connection. That's why this is not very wide.
Right. Yeah.
Yeah.
Yeah, it is, and that's the thing about like network visualizations too. Is like this is a pretty picture, but like getting the like kind of sorting them by like the dense versus the sparse connections. That's always a challenge, or getting that information out in other ways. Like, I mean, I don't know if that's something we want to work on this summer, but just kind of put that aside. Is that like a lot of the network visualizations focus on like this type of thing where you see the connections and you can see that there are differences between like dense and sparse connections or in terms of their weights, but then it's like, well, which ones are which, and what is the significance and how are they organized. It's like it's always a challenge. Yeah. But this I like this. This shows a good. I think it sort of emerges that there's like a subset of neurons that are, where there's a strong connection there.
Yeah. So Bradley, you want me to like maybe like if I hover on this edge, then I can see which, I mean, it is connected. What is its pre-synaptic neuron? What is its post-synaptic neuron? And how many synapses are there? I can do that if you want that. I mean,
that would actually be good. Yeah.
yeah. Okay, I'll do that then.
Yeah.
So if I hover on that, then I can see. Yeah, I'll do that in the next meet maybe.
Okay, that sounds good. Yeah, this looks really good. This is impressive work, as usual. Yeah. And so the thing you were showing with the you had where there was like the network visualization, and then you had the weights, and you had the RNN, which was in between the time steps. So what is from the paper? I think it was the
Yeah.
evolved
Yeah.
GCN paper.
Uh-huh.
So what are they actually evolving the weights here in this case? Yeah.
Yeah, here, so like here, what is happening is, so there are multiple number of, uh, timestamp that is there, and in each timestamp, there can be different events that can happen. So one thing can be like new node that are coming. So here you can see apparently the number of nodes that is there, that are like 4, 6, 7. Total number of nodes are 7. Here you can see the number of nodes that increased to 8, maybe 3, 6, 9, 10. 10. From 7 to number of node that increased to 10. Here again it decreased. So it normally what it does is it can track if there is any new node that is coming at that time, point of time, or if there is any new edges that are coming. So suppose in in these two nodes there were no connection at now, but in this timestamp there might be new connection that can come here. So it can track that. So evolve GCN. So these are the things it can do.
Okay. That's good. Yeah.
Yeah.
I was thinking about that in terms of like,
This one, right?
yeah,
Our work.
yeah, but I also was thinking about this in terms of like artificial agents. Like, I don't know if you probably don't know like the stuff we're doing with Bradenberg vehicles, but we also have this Bradenberg vehicles track where we're like, we've been interested in like taking the Bradenberg vehicle and like building these connectomes within the vehicle, and having a network within that vehicle of a certain size and evolving the connections using evolutionary algorithms. So you would like evolve the nervous system, you'd add in nodes, you'd add in edges. And this is all mapping between like the sensor and effector. I'd have to like get into sort of describing how the vehicles operate and everything to like give you a better picture. But basically, it's this process of if you took each of these GCNs and they were, kind of like time points, and then in between you had a genetic algorithm which like evolved the connectome itself. Adding nodes, adding connections, changing the weights. That would be the kind of thing you're trying to do there. And it was a kind of, you get like some interesting results, but that's kind of like one application domain I can see for this. And it links back to C. elegans connectome, and that you can use the C. elegans connectome to sort of calibrate what the agent is doing with like a real connectome. So you'd say, okay, what does C. elegans connectome look like over time? If we maybe have steps where we take the C. elegans connectome data and evolve it or change it somehow, what does that look like? And I'm just kind of freestyling here, but I'm thinking about like the connection between this kind of method or this kind of like time step dependent evolution of a network and some of the things you've shown with C. elegans here.
Yeah. Okay. Okay.
So it's nothing for you to follow up on. I'm just kind of thinking out loud about where this has broader significance.
I understand.
Yeah.
Okay.
All right. Well, yeah. Thanks. That's a great update. Looks like
Thank
you've
you.
been making
Thanks.
a lot of progress on that.
Thanks.
Yeah. Yeah. So great. Thank you for that, Jayadratha, and thank you for your update, Vidhi. Looks like Jesse's here and Morgan's here. So hello.
Hello.
Hi. How are you?
Okay. Been a busy week for other things, but also very good in terms of again, I don't know if actually some of the folks on the East Coast maybe could join here, but data interaction things are going really well. I don't have time today to do the full presentation. I might just record it. I'm kind of in sorting out some other things right now. But it is basically set. So I do want to do the technical presentation, talk. And if there's any other things for professional development stuff to on people's mind, let me know. I could freestyle about some things right now, but I don't know how much time we have or what you wanted to do. I know I kind of came in a bit late here.
So you can go ahead and give your update or freestyle or whatever you want to do.
Yeah. The last few weeks, as I think I've said here before, I'm doing part of the I'm doing a micro MBA that's surprisingly relevant and interesting. That's going really well. And I'm doing more in the way of establishing some of the I don't know. I mean, you could say business, you could say consulting type stuff, but the developmental processes of things, and some of the one of the things that may be most relevant for this group that's come up in some data and direction things has been kind of when the art of justifying what you're doing and communicating to different either stakeholders, or when people say, why are you using this particular approach? And it's maybe more aligned with data ethics or communicating the selection of, communicating the outcomes. I think in the most general sense, it's about communicating the outcomes of why, you're doing this and how it impacts different stakeholders and whatnot. But one of the things that it's led to and I'm just starting to pitch this on develop this, and I'll eventually do like a formal call for proposals. I guess I can announce those two different things. And I'll say more about them in the orthogonal Slack and ahead. But one of them is a very general, to put it in very simple terms, it's sort of a essay contest that is about the voices and philosophy around technology in the future, but I'm kind of intentionally going to slant it away from a lot of the conventional voices and trying to find a way to center some alternate voices and perspectives in terms of what is justified philosophically or ethically in those discussions. That's sort of a broad thing that I'm figuring out how to do. And there's a certain group that I really enjoy what they're doing, but they put out an essay contest and they put out a reading list, and I feel like it's just very incomplete. And I'm kind of tired of people having certain things that are much more centered than others in that process. So I'm going to make my own through my own means, and more about that ahead. Less I don't know, lofty or more concrete. I'm also going to open up I don't know quite what to call it yet, but through some conversations, and dealings with the data interaction folks, there's been a little bit of seeking how to justify the point of data ethics or responsible AI. Like I won't go into the criticisms of people in those spaces, but there's a sense of how do we talk about the at its core, I think it's developing a literacy of the current space of technology development. Whatever your take on it, whether you're pro open source or anti open source, or you think open source is a solution, you see open source as the way to democratize or decentralize certain things or not. Like, it's sort of this literacy component to the broader arena in which we're developing these actual pieces of code or software or tools or products or apps or whatever. And I think there's just been a really good amount of talk about that this week. And I have a project of sorts in development that offers first first time or basically people in the internship program, and they're all, you know, people who are not experts. And I don't really know that there's a few I would say are experts in the arena of, I say, responsible AI or data ethics. But I want to center a little bit of where they are and their views about it, and then also get people used to explaining to a specific audience or target. A lot of times there's these, you know, on one side you have open washing or tech washing or ethics washing, and then on the other side of the coin there's a little bit of generically situated, this is wrong, this is bad, this should be different. And I find that to be like, that may be true, normatively or ethically or whatever, but like constructively and strategically, the arguments need to be tailored to specific actors or stakeholders or targets in general. So I'm devising a bit of a plan for how to create not exactly a document, not a report, but sort of a an opportunity for people, regardless of if it's like some people are in the data and direction thing, or just like undergraduate computer engineering major who is totally brand new. But like I want him to go through a very similar process to the like a PhD student is doing, in terms of identifying the argument, the target, and the context. So that's something that's in the works for those things, and they will spawn from like real discussion. And I'll give a broader update about like what's. I should probably give an update on data and direction like in tomorrow's meeting at large, and I may have more time to do it then.
Okay.
But it's been a very very good so far on that front. As always, there's sort of this ever shifting tide of events and priorities and things happening here in the United States that kind of impact a lot of, you know, the space we're doing. I don't have a lot to say about that right now, but my sort of closing comment for today is, I think I will close on. We've talked in this group a little bit about something that I think I've said here is basically organizational literacy. And between the other internships, between this Google Summer of Code and the Summer Cohort, and between also some of our work, our work, with New York Celebration of Women in Computing, which is a conference that we have attended to, or I've been a co-chair for a while, but we've also presented at through the lab. There's a very there's sort of a continued refinement of how do we explain or get people into organizational literacy, both. And what I mean by organizational literacy is like how an organization is functioning and what your particular role in it is, and how the you know, I don't want to say the value chain or the chain of command, but like what leverage you have and what you're subjected to depending on where you are in the organization. Now, in the open source or startup or innovation community, it can be a very different structure, and it's interesting when you're kind of working on a flatter hierarchy with a kind of ragtag group of people like at a hackathon, or people that are just forming a startup or forming an idea, versus a very corporate bureaucratic top-down hierarchy, you know, with these different things going on. But I think there's sort of a fundamental, one of the major things that keeps coming across many of these areas is like, what do you do in those different situations? And also like I've actually saved this chart from a long time ago. I think it was 2 or 3 years ago, maybe 4 years ago, at NICWIC, where one of the keynote speakers one of the main things they talked about was understanding the roles you have between a supervisor or a mentor or a colleague, and how in your place of work, those are three very different relationships depending on responsibilities and what you can do and what you owe them and what you can ask of them, and sort of how to handle those different things. And so my conclusion is, as always, if you have any questions about navigating those spaces, I know we talk predominantly about code and coding here and these messages and the projects proper, but as sort of the mentoring component of what we're doing, feel free to ask about that. And two, I think I will follow up with you about this particularly, Bradley, but like there's definitely some things that I want to develop in kind of a curriculum sense therein. And I know we've talked a little bit about, like, you have your project management course. We've talked a lot about different forms of project management and what it means to do that in open source spaces and whatnot. But I think there's some a nice sort of critical mass of things emerging in this space. So more ahead on that. I'll leave it at that for now. And if there's any questions, I can follow up with them.
All right. Yeah, that sounds great. And I like the idea of having a curriculum around some of these things that maybe there isn't a curriculum around, or, there's an informal curriculum, but sometimes it's just kind of the water you swim in. And it's like nice to have a curriculum around that stuff, thinking about it critically, etc.
Yeah, and particularly what I'm developing some of my own, like, I'm doing more and more in the space of getting people to, I don't know, like the rapidity of development of a lot of things right now in terms of both AI and agential stuff, and how companies or products or groups making these things are doing is very, in one sense it's the same as it's always been, but in another sense there's just a certain rapidity to things now, and a lot of the organizational literacy, even as a broad concept, you can say, you can break it down, like I said, to like startup life or open source or low flat hierarchy versus more established things. But there's also sort of a 5 years ago versus now. And then what I'm seeing is like a tremendous amount of advice that's given to undergraduates in particular, but people, early career folks in general, feels is very well meaning, but it's not necessarily relevant to today's world. So I find that to be, I don't know, a sort of due diligence that I'm attempting to take seriously in making newer approaches to this. So yeah, I'll leave it at that.
Okay.
But it's good to hear everybody's updates too. So thank you.
Yeah. Well, great. Thank you. All right. So it looks like Sarrah had to leave early. That's fine. And she was just saying that Jaya's presentation was great. A lot of nice visualization. So thank you again for that. I wanted to go over some things on documentation because I think those are quite useful. We talked in your midterm reviews. I talked about how I'm looking forward to people generating some documentation around their code. And documentation is an interesting topic because although it's central to a lot of technology, we don't often think about it as much. And that's a artifact of a lot of the way in which we do project management and software development. So we stress like getting things out the door quickly, optimizing or scheduling, working on features and having that plan in hand, or just kind of working out ideas to see what works. But we don't think about the documentation. And some of that, quite frankly, I think is just because a lot of people don't want to read things. So, it's like maybe that's the problem. But and documentation doesn't have to be just text. It can be videos. It can be anything that helps you, facilitates your interaction with software or maybe any sort of product more generally. So the first thing I want to talk about is kind of thinking about like the history of documentation. And it goes all the way back to Charles Babbage's difference engine, where you have this technical documentation that's more about the specs of the machine. And this was, of course, a mechanical computer. So you had to know like the specs of the machine to be able to program it, to be able to use it. And, because it was a very different idea from what we were used to in the world. So you had to give people this sort of overview of what it was. And, that's kind of how they dealt with that documentation. There wasn't much about like, detail about how to use it necessarily. It's just like what it is and the mechanical aspects of it. Well, anyways, that was a very early stab at technical documentation. More recent was the Apple II reference manual. This was, of course, when personal computers were just becoming prevalent. People would buy a personal computer, and oftentimes they wouldn't have not had much experience with personal computing or computing at all. So you would buy like an Apple II and you'd start using it, and you'd have to figure out how to use it. How is it useful? How do you do things, and how do you make things happen on the screen? And so this is the reference manual. It's very thick. What's interesting about this is they actually have examples of how to produce programs, how to write programs. And so, you'd never buy a laptop today and they don't have like a programming manual inside the documentation. In fact, if you buy a laptop today, you get very little documentation at all. So, maybe that's because people know how to use laptops. Maybe it's because there's, people don't repair their own laptops, or they don't need technical specs to understand what it does. Or in this case with the Apple II, there was a dearth of software, so you had to sometimes create your own software. So this was all kind of in the documentation. But I wanted to highlight this thing on the right, which is how to write effective documentation for your open source project. This is an article from opensource.com. And it kind of talks about like this point of view on open source documentation. So this is where you have a project where you put the code up on GitHub, and then you want to bring people into the project. You want to introduce them to the software, because just dumping something out on GitHub is, I don't know how to use that. I don't know how to use that resource. So they talk about maybe the best practices for this. The first point they make is that most traffic to your project will lead to the documentation, and then most of that will lead to the get started doc. So it's important to have good documentation, to spend time on it, but not maybe spend too much time on it, as it needs to be, somewhat refined, because people don't want to wade through a bunch of documentation to use something that maybe they already, like, a lot of the documentation might be redundant or irrelevant to actually getting started. So you want to have sort of this lean documentation, but also have very clear organizational goals. And then, you need to update your documentation. So a lot of times organizations or individual projects will try to make serial updates to the documentation once it's generated. So you need to contain essential information, but that essential information can change from version to version, so it needs to be updated. A lot of times there's an incentives problem, which is that, when someone contributes to a project, when they contribute code, they often don't contribute documentation. So how do you induce people to write that documentation with the code? So along with documentation, we have code comments, and code comments are important for sort of generating the documentation, because the code comments, you don't want that to be in the documentation, but you also want people to understand the code. So a lot of times code comments, if you just kind of play it by ear, tend to be redundant. They tend to describe something that's obvious, and they don't give a lot of insight into what the code actually does. So there are different, this article here, The Engineer's Guide to Writing Meaningful Code Comments. This talks about two different types of code commenting. You have the module level, which is where you have blocks of code and you try to describe what the output might be, what the context is for the code, and anything that cannot be understood at a glance. Now, that may sound like something that it can replace documentation, but that's actually not what we're trying to get at. What we're trying to get at is we're trying to take code commenting and use it as sort of like an intermediary between things that are not particularly obvious from the code and maybe more detail about why something exists or, how you implement something. So you might, for example, have code comments that describe the output, the variations in the output, the context in which you might use a block of code, and then the documentation gives you an example of how that's useful or demos of how you might use the code in real life situations. So there's also the logical level rules for code commenting. Those are contextual comments. And then, of course, in terms of module level rules for code commenting, that can add units of precision. There are these units of inclusivity and exclusivity, and the way we treat things like null values and things like that. And so sometimes we want to comment things in the code, sometimes we want to move that to the documentation. So items that should be incorporated into the documentation or made into an issue, those are things we want to try to do in lieu of commenting. So you really have to think about this in terms of what is a good comment, what is not redundant, but also describes something going on immediate in the code. And then if it's maybe something to do like later to improve the code, or if it's something that kind of describes the function of the code more in depth, then you want to move that to the documentation or maybe into, like, say, a GitHub issue. And so this, the connection between code comments and documentation have to do with technical debt. I like this topic of technical debt. I teach it on a regular basis. And basically, technical debt, as maybe you are aware, is this that, when you kind of do things in a way that's fast and quick and expedient, you oftentimes take shortcuts. You put in redundant code comments, you don't put in any code comments, you don't write documentation. And as a result of that, over time, your quality suffers. And so over time, if you just kind of say, forget about the code comments, forget about the documentation, over time, you need those checks to make sure that the code is, that you're there's accountability in the code and accountability in how the code is used. And if those things don't exist, then you end up with a lower quality code because code gets changed, people don't know what's going on, and this technical debt mounts. So it's very much connected to project management, connected to functional code, and connected to maintenance. There are documentation style guides. So this is a style guide, documentation best practices. In this case, they're suggesting that documentation exists as a tree where you have maybe a README file at the top or a get started file at the top. And then as you get more specific with your documentation, it becomes like this tree that branches out. And what's interesting is that sometimes documentation works best when that tree is not only there at different levels of specificity, but is frequently trimmed down. And they use the analogy of a bonsai tree, where you have to trim the tree to make it, to keep it in shape and growing. And so this is, your updating of your documentation just doesn't involve editing. It doesn't involve being relevant, but it involves changing the documentation and how it's connected and getting rid of old documentation that's not relevant, combining topics, merging things, but also splitting things up maybe that need more clarification. They also recommend changing documentation in the same pull request as the code so that those things are synchronized, so you don't say, well, I'll get to it later, and then never get around to it. And then they make this point that we should write for humans first and computers second. So you shouldn't worry about writing for like the expert coder or writing as if like the computer is going to use the code or the computer is going to make later changes. Humans are doing this, so we should write at a very high level for humans, or I guess maybe a low level for humans, something that isn't like very technically focused. And then maybe, you know, if you think about that tree, you write documentation that's very general at the top, and then as you branch down into the depths of like specificity, you make things more and more technical. So there are all sorts of strategies for dealing with how to design documentation and make it useful to people. So there are different types of documents, you know, depending on what you want to do, and you should have a lot of different types of documents, especially if you have a very large project. You should do things like have frequently asked questions. You should have cookbooks, which give like tutorials and how-tos. You should have readmes, which are showcases or get started files, which tell you something initially about the project. You should have technical details and reference files that kind of follow from the showcase. And then you should have maybe a blog with blog posts where you can answer why questions. So that's very common where, you know, that's what we've been talking about this summer with having a blog accompanying your project. Why do you want to do that? Because you want to answer why questions. You want to showcase what you're doing, but then say why it's important or why something needs to exist. It's a very important part of, especially when you're trying to guide people through the roadmap or the big picture of the project. And so this is, of course, a choice, a strategy to invest in documentation. And a lot of agile projects or lean projects do not do this. This, in fact, is the philosophy that documentation should be as lean as possible. We shouldn't really invest, in fact, very much at all in documentation until we sort of finish up our projects. And there's a logic to that. You know, we can have a high level plan, we can have maybe some minimal requirements, but spending a lot of time on documentation is burdensome and, depending on the project, unnecessary. But also, we run the risk of not investing enough in documentation. If we compare that with the traditional view of project management or of software engineering, which is encapsulated in something like waterfall management, you get this, you know, a lot of effort that needs to be put in up front. This is where you have every sort of thing in your project detailed, design specs, requirements, and a project plan, and all that comes up front, which helps you with documentation later, but it still doesn't preclude you from having to spend more time at the end in terms of writing user docs and ops docs and things like that. So the total effort can be explosive if you really have like a documentation first strategy. But if you have a documentation only when needed strategy, it can be disadvantageous as well. So coming up with a good strategy is key here. And I mean, these are just two examples, kind of two extremes. A lot of times you can pick like a middle path here. Finally, I wanted to talk about this slide. This is I'm not going to do too much on this. It's just to say that like when you take this doc strategy and put it into practice, you have to think about how people will use those docs. And so there are many different. This is a study from Coda.io where they have, you know, they're a docs company, so they wanted to understand how teams use their docs, use their product. And it turns out that depending on your documentation strategy, people will use those docs in different ways. Sometimes it drives the team, and maybe it drives them dysfunctional, maybe it makes it more functional, which is kind of why we do docs. But sometimes the docs, you know, can fit the team, and sometimes it fits the team poorly. So there are these different strategies that they identified based on the number and size of docs that were, implemented, and then the teams organize themselves around those. They use them, And sometimes the take home message of this is sometimes your team finds the docs very useful and they end up organizing their work around good docs. And sometimes they find them not to be useful. And when they find them not to be useful, they can both make your team dysfunctional and be a huge waste of time and effort in terms of producing them. As we saw in the last slide, you can spend a lot of time and effort and resources building docs sort of a priori, and then it's not useful to the team, so there's no point in doing it. So there's this weird, or this maybe critical interaction between the team members, and the docs. So, okay, that's, I think, enough for today. Thanks for attending. I see we lost a couple of people, but that's okay. Any comments or questions on that presentation?
Yeah, can you just share these slides somewhere, like on the GSoC open source channel itself or something?
Yeah, I will.
Okay.
Yeah, all right.
Okay.
All right.
Yep, thank you.
All right, thank you.
I'll see
Jayadratha,
you
did
tomorrow.
you? Okay.
Yeah.
Did you have something to say, or? Okay. All right, well, thank you.
Yep,
See you
see you
next
tomorrow.
week.
Bye.
Bye.